All right, forces and motions. So this is possibly one of the hardest topics in the praxis, especially for people who don't just love science, and are just trying to get through this test. So let's go through this stuff one by one. All right, forces and motions. So first thing we have to look at is gravity and increasing speed of a dropping ball. This is a real common praxis question. As an object falls, its speed increases due to being pulled on by gravity. The acceleration of gravity near Earth's surface is 9.81 meters per second squared. So you don't need to know that formula. All you really need to know is that the speed of a dropping ball increases due to gravity. Just knowing that is enough. All right, the next one, Newton's three laws. So we're going to have to be familiar with these. We'll go over each of these. But again, it's just real brief. Newton's first law is inertia. Object will remain in the state of motion unless a force acts to change that motion. Right? So that's the first law. Second law, force equals mass times acceleration. Just a real simple formula. Third law, all forces in the universe occur in equal but oppositely directed pairs. So going over this for Newton's three laws, if we see inertia, we know that's the first law. For the second law, we know it's that formula for force. Third law, equal but oppositely directed pairs. So those are our Newton's three laws. Okay, four laws of thermodynamics. This can seem like a lot. We'll go through each of these and then try to go over how to remember them for the test. Zeroth law. If two systems are in thermal equilibrium with a third system, they are in thermal equilibrium with each other. This law helps define our notion of temperature. Thermal equilibrium essentially means that no heat flows between them. Okay. First law. First law states that when energy passes into or out of a system, the system's internal energy changes in accord with the law of conservation of energy. So the first law really encompasses the law of conservation of energy, the concept of internal energy, and also work, transferring energy to or from a system. That's all about the first law. The second law and the third law are going to focus on entropy. When you see the word entropy, decent chance we don't know what it means, which makes it really hard to interpret the second and third law. Entropy just basically means some measure of disorder in thermodynamics. So that's still even a little bit confusing. Second law, the sum of entropies of the interacting thermodynamic systems increases. Third law, the entropy of a system approaches a constant value as temperature approaches absolute zero. So you might see a question on the second or third law, not as likely as the first law. If you do, remembering second or third law, think entropy. The second law has to do with sum. Third law, absolute zero. Okay, and then we have types of friction. We'll go through each of these. And you want to know these as well as be able to know an example. For static friction, when a force is applied to an object but it does not cause it to move, such as pushing on a wall, this would be considered static friction. Fluid friction, when an object moves through a fluid, meaning either through a liquid or a gas. So swimming or skydiving would be good examples there. Sliding friction, when solid surfaces slide over each other, such as falling on the ground. And then rolling friction, when an object rolls over another object, such as anything with wheels or a ball, that will be rolling friction.